What's up, everybody? I'm here today with my personal assistant, Boone.
Hi.
And we are going to do a classic chemical reaction demo for you today that is coming to you from a request that I received from one of our viewers at home. So this is the classic elephant toothpaste. It's a very easy experiment. Your kids will love to do this at home. Just make sure that as you're going through it, you're getting the science out of it. So some of the things that we're going to want to be looking for and talking about here are how can we tell a chemical reaction is happening? There's obviously going to be fizzing happening, which shows the release of a gas. That's probably the biggest indicator or the biggest piece of evidence that a chemical reaction is happening. The gas is going to be caught in dish soap, which we've already added. I'm going to talk about the ingredients in a second. And then depending on the strength of the hydrogen peroxide that you use, it might actually even get a little bit warm, which shows that heat is being released as well, which is evidence of a chemical reaction. So in our empty water bottle here, and I'm doing this on a plate to catch anything that comes from it, I've already got some dry active yeast mixed with a little bit of warm water. The exact amounts are 1 tablespoon of yeast, or excuse me, 1 teaspoon of the dry active yeast, and 2 tablespoons of warm water. I also added a few drops of blue food coloring, and I put a big squirt of dish soap just down in and around and a little bit on the sides. So that's what's already in the bottle. Now to that, I'm going to add hydrogen peroxide. Now in the stores, you can buy anything from 1 to 6% typically. If I were going to do this demo in my lab, I would use laboratory or food grade hydrogen peroxide, which is much, much stronger, ranging anywhere from 30 to 60%. That's not something that you can typically just buy at the store, and you wouldn't want to mess around with that in your own home. So if I were able to do this in my lab, it would be a much bigger reaction. But this is a nice one that you can do at home, and your kids will really enjoy it. So I had 3% hydrogen peroxide. Do you want to go? Can you go grab that for me on the counter, the peroxide over there, so I can show them? It was 3%. I wanted to try to get a little bit bigger of a reaction, the brown bottle. And so what I actually did, and don't let your kids do this part on their own. You're going to want to monitor this. Okay, so see here I had 3% hydrogen peroxide is what I was using. But I wanted it to be a little bit stronger. So because water boils at 100 degrees and hydrogen peroxide boils at about 150, I put a little bit of the hydrogen peroxide into a saucepan on the stove, and I let it boil for a while to try to get rid of some of the water to make it a stronger solution. So the water evaporated, leaving the hydrogen peroxide behind. So it's going to be probably closer to a 4 or 5% solution that I'm working with here. Again, you wouldn't want your kids to obviously be using the stove unattended, so please make sure that you would help them with that part. That process is called distillation, when we're removing the water from the mixture. So that's all that I've got going in here right now is some hydrogen peroxide. It is still a little bit warm, which might help our reaction, but let's see what happens. Do you want to hold the bottle? All right, ready? Here we go. And then when I tell you to let go, all right, I'm going to pour this in.
Let go?
All right, let go, yep. So there it goes. Woo! All right, and there you have it. And it is making a little bit of a mess on this plate, so make sure that you... Can we touch it? Feel on the outside, see if it's giving... Oh, and look at, see how it's giving off steam?
Yeah.
Yeah, so it's giving off heat. Don't touch it, because it has peroxide in it. It'll sting your fingers a little bit, but you can feel the heat coming right off of it. Okay, so there you have it. That's a pretty fun one and a pretty easy one to do at home. You get a nice chemical reaction here. If you end up doing it, send me some pictures. I'd love to see it, wouldn't we? Thanks, guys.